When I was young, I traveled around the world as a backpacker. I made it a point to travel solo and without reservation. In those days, the visa requirements were quite light. There was no mobile phones, and travelers like me relied on the Lonely Planet guidebook. I traveled to many places where they did not speak English, like Japan and Thailand. The reason I'm bringing this old memory back is that I was struggling in how to explain this very difficult section in a way that is not boring, non-academic, yet it would bring clarity in the reader. My backpacking days served me in many other ways, like it built my confidence, leadership capacity, social skills, and so on. But I did not imagine that it would help me to teach statistics. Whenever I reached a new place alone, I never was worried because I knew that whether it was in the high-tech city of Tokyo or the slums of Mumbai, human needs and the way they organized their lives was very similar. The language was different, the architectures were different, the culture was different, but the objective is all the same. We need to eat, we need to sleep, we need to go from point A to point B, we need some stability. Nothing can be gotten for free. Everybody wants to be appreciated. A smile goes a long way everywhere in the world. At the core, we are all protected by some forces from the worst scenarios. Now I'm linking my travel experience with this chapter on statistics without getting in further details of my backpacking days. Statistics, for many, whether they are bachelor level students or PhD aspirants or even writers, appear dizzyingly complex, large. They speak a language we don't understand. It seems there is no beginning and no end, no structure in that world of statistics. There should be a map, but instead we realize it appears to be as disorganized as the slums. So many of us who need statistics or who need to settle in that statistics land start to learn the language, find the shortcuts from point A to point B, but it's a tedious process that takes years. However, what I realized as a backpacker is that I didn't need to learn the language and the details of the city that I flew into to get around and get the best of that city, and yet protect myself from imminent danger. I even got lost or swindled many times, but I used the concepts that I would have used at home to find my way and save myself. All I needed was to translate it in that particular situation and country. Similarly, I want to tell you, my dear reader, that there is a better way to learn statistics, as I am offering in this chapter using the four-brain learning approach. The beginning is this analogy with traveling. I don't need to know the Japanese word for water. All I need to know is that I am thirsty, and then I'll find a way to communicate that to the locals. However, the current textbooks and syllabus are teaching us the language first and forcing us to memorize them without putting them in context of concepts that we already know. So in our minds, the new terms are standalones, disconnected with anything else we know. We are lost in the city or in the slums. However, in all my travels, I realized that even the slums and the cities of futures like Tokyo and Yokohama have much in common. There's an entry point and there's an exit. There are clusters, there's a center, there's suburbs, there are various modes of transport, there are shops, there are residences, offices, temples, churches, whatever. Similarly, statistics isn't something separate from our daily cognition. They follow a same pattern, and this is what I'll be showing you in this section. There is actually no mystery. It's just poor pedagogy based on a single brain learning approach that has caused seekers of the truth like you and me not to be able to use statistics. But after this chapter, the bars will be so lowered that anybody who can read the upcoming pages will be able to navigate the landscape of statistics. Like I traveled solo unknown cities in my youth without mobile phones. So let us begin our journey into the statistics land. For your reference, you can take a look at the diagram below, which consists of a table and some graphs. The first column consists of the statistical concepts used in the subject. This is nothing more than learning that in Hindi, pani means water. Then in the second column, we have the everyday language that we use that actually means that word. The third column contains of phrases or idioms that are related to that terminology. The third column contains some famous and interesting uses of that concept. And the fourth column consists of some examples with numbers, since we are dealing with statistics. Instead of me just reading out the chart, I'll be explaining to you the same 12 terminologies, which are the most crucial ones in statistics, by starting with the concept around them. A baker bakes bread, but he might be called Mr. Newman. So while we could start with introducing Mr. Newman and then telling that he's a baker, that means that he bakes bread. We will start with looking for bread because we are hungry, then looking for a baker who makes the bread, and finding out that Mr. Newman is a local baker. That would help us lower the obstacle level in our cognition. So let us begin. Every day we talk about averages. For example, we tend to call someone average Joe or average Jane, indicating he's just a normal guy or girl. We follow the rule of thumb. Then whenever we read in the newspaper, we come across such interesting articles that say the average adult human sleeps about 7 to 8 hours a night. Many of us are sports fan, and we love to find out the various averages in sports, like what's the average score for that particular player per game. Well, In statistics, this concept is coined as mean. That's not hard, is it? I still remember in my school days when we used to be put in lines and we would be told to arrange ourselves in the ascending height, meaning that the shortest student is at the front and the tallest one is at the back. I used to be around in the middle. When we asked where is a particular building, we tend to say it's in the middle of the road. My favorite answer when somebody asks me what kind of student you are, I would say I'm in the middle, 50% mark. Then in the news, we often hear the word of a certain amount being the middle income. Well, that's what median means in statistics. So in a group of 5 people with salaries of 30K, 40K, 50K, 70K, and 100K, the median salary thus is 50K. Isn't it very similar to how we were made to stand in a line height-wise when we were children? Whenever we walk in the streets, we tend to notice some of the things that are most common and that appear the most often. In a city like Japan, most people live in apartments, while in slums, most people will have to share room with many others. We also tend to notice what's the most common car that drives around in your city. We have our most popular stars, the crowd favorite. The technical word for that is mode. Do you know what's the most frequently sold size of shoes? That would be the mode. In a survey of favorite colors taken in a samples of 100 people, if blue was chosen by 45 of them, then it would be the mode. In a city, if the highest temperature is 35 degrees centigrade in summer and the lowest is minus 6.7 degrees centigrade in winter, then the range is 41.7 degrees centigrade. So temperature in the other 363 days must be within those upper and lower limit. In this way, range is another statistical term. In our day-to-day lingo, we also use the word full span, or the difference between the extremes from top to bottom all over the map. So in what division did you pass? The first, second, or third? Are you A grade student, B grade student, C grade student, or D grade student? This process of dividing the group and making segments, finding the top tier and the bottom of the barrel, is coined as quartile in statistics. We hate our parents when they say that you always do something wrongly and we never do something right, when in fact we did it only a few times or did not do it a few times. This is called frequency in statistics. We have phrases like once in a blue moon, as a rule, on a regular basis, that indicate frequency. So far, we have discussed the terms for basic statistics. Now we are going to venture into more advanced statistics. However, no matter how tall the skyscraper is, the function is as the same as a slum. You need to sleep in there, eat in there, and it must protect you from the weather elements. The only difference is it's taller, more organized, and more artistic. The same goes with advanced statistics and its relation with day-to-day concepts. The statisticians may make us believe that they have discovered something new by presenting us with difficult terminology and formulas, but in fact it's something that we humans do anyways. They just formalized it and turned it into a framework that can be used for scientific investigation. Kudos to them, but it's time that we democratize statistics, and everyone should have access to it. When I was young, there was this girl in my college who always happened to be cafeteria at the same time as me. Now, this girl was pretty, of course. The question in such a case is her being at the same place as me, consequently for so many days, related, associated, or linked with me? Well, that is what statisticians call correlation. Is there a correlation between me being in the cafeteria at a particular time and that pretty girl being in the cafeteria at that same time? I wish I knew statistics back then. What I would have done is I would have calculated the correlation coefficient, and I would have maybe concluded that there is a strong correlation. So maybe she really liked me, which would be the causation. Unfortunately, I never got that far, and college ended. Correlations are in our everyday lives. Do you always add on weight when you travel or when you have parties? Then there would be a correlation. Then there are many cases where there is a correlation but no causation, like the relationship between the sales of ice cream and the sales of sunscreen. One did not cause the other. The cause would most probably be the increased heat or temperature that causes the increase both. Again, this starts with a correlation. Another very important correlation that students are told over and over again is the relationship between the amount of study hours and the test scores. The correlation coefficient R is equal to 0.9, which is very high, 1 being the highest. At least that's what research says. So your parents were not wrong when they said to you, the more you study, the higher the marks you'll get. It's statistically proven. So the bottom line is, statistics is something that we do every day. Time to banish the gatekeepers and enter into this land of statistics and explore the immense treasures that it beholds for all of us. Similar terms are t-statistics and chi-square. They are also trying to establish whether there's a relationship between two data sets or two phenomenons. The reason we need 3 measurement tools to measure correlation is that there are 3 combinations of relationships. The 2 things that we want to investigate might be numerical, or categorical, or categorical, numerical. And that's what those 3 measures do, respectively. For example, find the correlation between the test hours and study hours and the test results. We'll use correlation coefficient because it's a numerical type of data set. Sometimes we need to compare apples to oranges or head to head. Then we'd use t-statistics because it's a categorical numerical data set. Like for drug testing, and to show it is effective compared to a placebo control group. The same measure of the statistics would be used to compare a new teaching method to the old one between various control groups and experiment control groups. Sometimes we need to find a relationship between a person's age and their preference of a particular brand, which are both categories, so we'd use the chi-square. It's that simple. If you are traveling alone, you can ride a bike, cycle. If you are traveling two of you, you can ride a motorbike. And if you are traveling 4 or 5 of you, then you should take a car. Not that hard, is it? Now the next concept is a bit different. Earlier we established correlation, meaning that the two phenomena have a relationship or not. However, we need to answer a very common question like, could this happen by accident? Could that pretty girl in my college arrive at the same time at the cafeteria as me? Was it just a fluke? Well, this answer is given by a term called the p-value. A very common longitudinal study, meaning that we study two data sets in a technical way, is the relationship between DUI or driving under influence and car accidents. The p-value is very low, meaning that it's a very significant relationship. It simply means that it's not a fluke and it's not occurring by random. Most likely there's a causation relationship between DUI and accidents. Similarly, if a study reveals that a new fertilizer has a p-value of 2% on the positive yield for that year, it means that it was not by random chance or by some other factors. The fertilizer really works. So now that we know that two phenomena or data sets are related and they are not occurring by accident, the next question that is very logical is to make a prediction. Like if I came earlier by 5 minutes, by how much time that pretty girl would come earlier the next day so as not to miss me. We'd also want to know for every extra hour that I study, how much can I expect my test scores to increase. We could also want to know what will be the yield increase for every unit increase in the use of the fertilizer. Well, this prediction is coined as regression in statistics, and the number like 2 times, 3 times increase is called the regression coefficient. It's that simple. Finally, statistics in our daily lives deal with questions like what are the odds, what's the bet, what's the probability of winning the lottery, or the likelihood of rain tomorrow. Surprisingly, there is a formula for that based on the earlier statistical operations we have talked about. It's usually done in a combination of regression that we just covered. So it always goes like the probability of rain tomorrow is 40% based on the statistical model that factors in variables like humidity, fast-moving colds, barometric pressure, each factor contributing to the final forecast. In order to answer this 40%, all the correlation and the p-value and the regression would have been completed. And in the case of weather forecasting, advanced diagnostic and predicting models are used. We'll talk about in the later sections. But again, there's nothing alarming about it. It's just a taller building, and will conduct their business of living at the 112th floor instead of the ground floor. It's the same. By now, you are very comfortable in statistics land. You don't need to just learn a new language. All you need to do is translate what you need in the language that you are supposed to converse in the new land, but do it only when you need it. Now let's look at the several graphs in the diagram below. In this section I've just brought some very common diagrams, but statistics uses more diagrams, as we'll find out in later sections. Throughout my counseling sessions, I've realized that people intuitively, naturally understand diagrams. So it might be about statistics, but such a human way to understand life. The first one is a line diagram for life expectancy. It consists of the x-axis and y-axis, showing the period in time starting from 1800 to 2025, I think. Then in the y-axis, it shows the average lifespan. As you can see, it has increased 42 years from 1800 till now in 2023, as per the diagram. There are some droughts you can see. They represent the two world wars and the recent corona epidemic. So that's what this diagram is telling. That's visual statistics. The other graph is the bell curve, three of them here. The x-axis represents height, starting from 140 centimeters to 240 centimeters. And the three bell curves represent the height of women, men, and NBA players. All that this diagram shows is the frequency distribution. It just shows that, for example, in the case of men, most men are around 170 centimeters, and the number of men who are taller than that decreases in number, and the same goes for those who are less than 170 centimeters. This is what the bell curve tells. The particular diagram is saying that most NBA players are taller than the men, and most men are taller than women. The next diagram is a bar diagram showing how sales of a particular product in a particular company changes over a period of time. The x-axis represents the months and the y-axis represents the sales volume. The line represents the sales projection. Next diagram is the stock chart, or another form of line diagram, which represents a fluctuation of share prices over time. Again, the two lines represents the projections. The last diagram is the popular pie chart. This one represents how the population is distributed across the various countries. It shows that China and India have got 17 and 15% of the population. So in this way, you now know something about the diagrams of statistics. Remember, it's nothing more than a representation of a restaurant with a fork and a knife, or of a male and female toilet with the stick diagram of a male and a female stuck outside the door. Diagrams are made to simplify understanding, not to complicate it. When I was traveling in Japan, I relied a lot on those diagrams, especially when I needed to go for the toilet. All I needed to do was look at the male stick diagram. instead of trying to find out how toilet is written in Japanese. So by the end of this section, I'm sure that you are no more scared by terminology used in statistics, which we cannot do without when we are in statistics land. I'm sure that I traveled smoothly around the world as a backpacker without a phone. You too will be able to navigate statistics land and master this subject.